So nitric acid should be the lots of times that we've encountered it. So we've got aqueous here, aqueous things, and we've got the salt, zinc nitrate. Zinc is 2 plus, nitrate's 1 minus, so I need 2 lots of the nitrate. Aqueous. Hydrogen gas is always H2. You can never find hydrogen by itself. Okay, and it's gas at room temperature. Right, and if you're looking at it, there should be one obvious thing that's wrong with it. There's the nitrates out of balance and the hydrogens are out of balance, and the 2 solves that there. So I might just give it a bit of spacing, and then it's done. I'm going to go some pink. All right, got sulfuric acid reacts with manganese metal to form a salt plus hydrogen gas. We're going to go we'll go the metal first. So manganese, not a common metal. That's Mn. I imagine a lot of people would be writing Mg, thinking it's magnesium. Got sulfuric acid, H2SO4, aqueous. And our salt is manganese sulfate. It tells us manganese is 2 plus, sulfate is 2 minus. Ratio they come together is 1 to 1. And all salts are aqueous. Hydrogen gas is H2. Everything looks good. Nothing needs to be done there. I am running out of ideas for colours. Do I go into ugly colours? No. We start again. All right. Iron 3 chloride solution reacts with potassium carbonate solution to produce a precipitate of iron carbonate and a solution potassium chloride. Okay, so this is a precipitation reaction. This is when you mix, just to come up here, this is a precipitation reaction. This is when you mix 2 soluble salts and out of the solution precipitates a solid. Just like rain precipitates out from the sky, it's kind of where it gets its name from. So, iron 3 chloride. This is iron 3 plus, chlorine minus, potassium's K plus, carbonate's 3O2 minus, and that's all I need to do for this. So I've got 3 chlorines. It's going to be aqueous because it tells me it's not a solid. I know it doesn't quite fit the rules of these always soluble, like you don't have enough information to know that that's soluble, but you're going to have to accept it at this point. You've got potassium carbonate. It's going to be soluble because it's got a group 1 metal. All right, so iron 3 carbonate is our precipitate, which means it's the solid. Got iron is 3 plus, carbonate is 2 minus. So I'm just going to reverse cross and drop that thing. So the carbonate's 2 is coming down to iron, and then that. So I basically, in my head, swapped over their charges. It's a solid. And then I've got potassium chloride, which is my other soluble ionic compound, my salt. So 2 soluble reacts and produces 1 solid and 1 soluble compound. Right, out of whack, I'm just going to go in order. I see iron is 2 on the right-hand side and 1 on the left-hand side. And so I'm going to put a 2 there. That's going to make my chlorines 6 in total. So I'm going to come over here and put a 6. That's going to make my potassiums different. So I'm going to come and put a 3 there. And that looks like it fixed my carbonates as well, which is handy. And that's fully done. All right, after orange, we go green. Iron oxide produces oxygen from the air, reacts with iron metal. So this is what's called a combination or synthesis reaction, the first one on the list. This is just 2 things combining into one. It's actually the example in that one. Actually, sorry, no, that's not true. Iron solid plus oxygen. You never find oxygen by itself. It's always diatomic. Iron oxide. So oxygen, this is Fe2 minus, 2 plus, and this is oxygen 2 minus, 1 to 1 ratio. It's going to be a solid, Okay, if you've ever done this reaction, you've probably done magnesium plus oxygen and seen that white residue at the end. So that's how I know it's a solid. I've seen it before. And you got iron oxide, and you're going to have to put a 2 there to get the oxygens balanced, and a 2 there to get the ions balanced because of that. Okay, after pink, after green, purple. Okay, calcium metal reacts with oxygen. Oxygen and calcium blocks. Okay, this is this is the same thing. Easy. Calcium solid plus oxygen gas goes to calcium oxide solid. 2. Easy. After purple comes light blue. Okay. Not a very easy one to pick. This is a precipitation reaction. And if you do a whole lesson on solubility, this one would be pretty easy to pick. If you go off my rules, nitrates are always soluble, so that zinc nitrate is going to be, zinc's always 2+, by the way. So the zinc aqueous, that's the first time zinc's been dropped. Sorry, the 2+ has been dropped. Sodium carbonate, aqueous, and group 1 metal, so sodium carbonate is always aqueous. Zinc carbonate doesn't have anything in that list that makes it always soluble, so that's what I'm pointing out. And so you got zinc carbonate solid plus sodium nitrate aqueous. And jumping straight into sodiums, 2 sodiums, boom, boom. That fixes everything. Done. Okay. After blue, we go yellow, everyone's favorite. Copper oxide plus hydrochloric acid goes to copper chloride plus water. Okay, so copper oxide, 1:1 ratio, 2+, 2-. We'll go solid. HCl, aqueous, all acids, aqueous. Copper chloride is like this, the 2 versus the -1, aqueous plus H2O. This isn't a type of reaction, by the way. I guess there is metal oxides. This is not the ones, anything that you'd be expected to know, so you'll never get a copper oxide in that. Copper oxide, like you'll never get a question that's just like that. They'll tell you what the products are. This is a combination reaction, so this is just an identification. So synthesis reaction, 2 things combining into one. This is a reaction that's actually used in the formation of sulfuric acid. So we got sulfate. Ooh, I gotta do my colors. What a yellow comes pink. Sulfur trioxide, which is actually a gas. And that's my advantage over you. You wouldn't be expected to know that. H2O, which is a liquid at room temperature, goes to H2SO4 aqueous. All right, what points out? Nothing. Perfect. After pink, we go orange. NH3 bubbles through sulfuric acid to form a salt ammonium sulfate. So NH3, gas tells you it's bubbling, or bubbling tells you it's gas. H2SO4 is water with stuff in it, aqueous. And you make ammonium sulfate. Okay, so I should probably say down here NH4 plus SO4 2-. So I actually need 2 lots of the nitrates to match the 1 sulfate. And because it's got ammonium in it, it's soluble. Might pause there. I'll keep going. Orange, green. Okay, so iron 2 sulfide is this. HCl.